Hello. Thanks for having me here. It's really an honor to be here. So I want to share with you guys today Uber's vision for the future of aerial ride sharing. And so to start off, to give some context, you have to look at, why is Uber doing this? And so Uber is on Earth to figure out how to move people around their cities. But there's a fundamental problem with cities today, which is congestion, emissions, and 50% of the people in the world live in cities today, and that number is projected within 20 years to be 6 billion people in cities around the world. And the cities are already struggling to serve the demand that these people bring. You have major congestion in Mexico City. Every year people spend 5 weeks in traffic. And so there needs to be kind of a fundamental shift in how we think about urban transportation. And so Uber is doing initiatives like bike sharing, like ride sharing through Uber Pool and Express Pool, and looking at different ways to move people around in the cities. But there's a fundamental limit to how we can use that space on the ground. So we have to look at what cities have done and take advantage of that third dimension. And so why is this happening now? We've been hearing about the future of flying cars for 40 years in Popular Mechanics, and people are like, okay, we've been hearing this for so long. Why is it now happening today? And there's a couple things coming together that are now making it possible through electric propulsion and battery technology, as well as these kind of multimodal solutions and being able to push a button and get a ride. And so all of these technologies coming together at the same time are allowing us to finally make this reality. And so how is Uber looking at how we design this system? And so this is a simulation of how people move around in the city of Los Angeles. And it looks at both the inflow and the outflow, as well as the total volume. And so we use the data set that we have, which you could argue is the most complete, one of the most complete data sets of how people move around the cities and the different modes and the different choices that they make. And so we can use this data combined with other data sources and look at how do we design a network that can optimally serve people. And so we're not just saying, okay, we think people want to go here, and so let's just go do it. It's really making data-driven decisions, looking at a full network optimization. And so again, we need to understand, will people actually take this trip? Right? We don't want to go build this system if nobody's going to use it. And so what we've done is done really deep studies, and we've gone out and done surveys to say, okay, if these are your options today, and we introduce this other option, figure out how many people would take this. And so looking at all of the trips that people take, which ones of those can we replace with urban air transport that will save you, an hour or more every day, and allow you to move around your city in a much more efficient way. And so from this, we've had to develop a set of vehicle requirements. So I'm the requirements lead at Uber. And so when thinking about how we design the system and how we design these vehicles, you have to keep this whole network in mind. And so a big kind of question right now in the urban air mobility space is, do you have a wing or not? How fast do you fly? And so you can look at the option of flying maybe 100 miles an hour or 150. And flying 100 to 150, you might think you start getting diminishing returns because you have those multimodal switching costs. You have to get to the skyport. You have to take off. So intuitively, it might seem that extra 50 miles an hour doesn't get you that much. But when you take the network level perspective and you think about the multimodal journey that these users are going to be taking, it shows you that actually you can double the radius that you can pull those passengers from, which means you quadruple the area. And by having a much larger demand pool, you can now batch these passengers much more efficiently, like we do with Uber Pool on the ground. And then we're dividing the costs across 4 people instead of 1 on every trip, which is really the key to making this an efficient and affordable network. And so the speed is just one example of places where we're really taking a network view of these requirements. We've looked at weight distributions in different cities that we intend to operate in, and the expected load factors in these vehicles. We looked at the speed ranges and how fast people need to go and what they're willing to pay for that time savings. One thing is in the infrastructure. We've taken the all-electric approach, one because of efficiency and because of emissions, but also the infrastructure is incredibly more complex if you have to build in the fire safety systems and the fueling systems that go along with a hybrid or a fueled aircraft. And so what has come out of this is a kind of unique set of requirements that has never really been seen in aviation before. There's kind of the traditional sizing mission where you have your takeoff, your cruise, your landing, and you have your range, your mass, your payload, and your speed. But the unique mission that comes out of this urban air mobility space is this kind of 3-hour sawtooth type pattern that we like to call it. And what this is you're taking these short flights, an average of only 25 miles. A lot of the criticism of electric flight is, you're never going to be able to do what an airplane today can do. And the answer is that we don't have to. We can take these 25-mile short trips with quick, rapid charging in between, cool the aircraft with that charging system, and be able to do these kind of 3-hour sprints and serve people with minimum time on ground and maximum efficiency. And so how do we then design these aircraft? So again, we can't design the aircraft without thinking about the network, and we also can't design the network without thinking of the capabilities of the technology. So here's an example kind of design trade that we've done at Uber. And so this is for a kind of standard lift plus cruise, separate propulsion systems, and trading off the battery size and the mission distance. So to get to 60 miles, which is really the range you need to serve a metropolitan area, there's kind of a minimum battery size that's going to get you to that range. But then also we've seen that you need to be able to do these 25-mile repeatable missions in order to serve the average mission that people want to travel. And you have to be able to do that for 3 hours to actually be able to get through that kind of rush hour and not have to do these long charges in the middle of the morning or evening rush. And so this has kind of driven us towards like a sort of design space. And so some of you may have seen this, the VTOL, it's been called the Wheel of Misfortune in the past. And very few of these concepts actually kind of made it to operational capabilities. There's a couple there that you've seen that are successful, the V-22, for example. But for the most part, a lot of these had trouble, and most of that was because of the complex mechanics and the gearboxes and the linkages that go along with combustion engines. And so with this new electric capability, we have a new wheel. Hopefully this one's the Wheel of Fortune. And so you can see some concepts of Aurora Flight Sciences up there, as Mike talked about, and concepts that range from an 18-rotor multi-rotor, to the lift plus cruise, to the tilt rotors, and so there's this massive wide open design space that we now have, and it's really exciting to see all the different concepts that are coming out. There's now over 100 concepts out in the public, and many more probably in stealth. So the Vertical Flight Society has been tracking all these and have a great website where you can see all of the action that's happening in this space. And so Uber has designed a couple concepts. We never intended to build a vehicle, but we wanted a common, we call these the common reference models. And these allow governments and academics to all engage on, okay, how do we see this future happening? And what do these type of vehicles look like? And so we worked with NASA, and we worked with different academic institutions, and we can now share this. You can download these models on our website, actually, and do the kind of analysis for yourself and play around with them. So we've designed a couple different concepts to show, we're not saying any one of these is the answer, but there's a really wide open space that you can use, and there's this whole new design freedom. And so we're working with partners. I said Uber's not building vehicle, but we're working with 5 incredible partners, each that bring their own expertise. You've got Pipistrel that won the Green Flight Challenge in 2011. Bell with incredible experience in vertical and transitioning aircraft. Embraer, obviously, great experience in certifying and manufacturing aircraft. Aurora, especially with their autonomy and with their now partnership with Boeing. And Karam Aircraft, also great history of vertical flight. And so we did actually an example trade study to see, we expect this growth of batteries, and you're going to hear more talks about that later. But even with cells that you can get today, we had our battery team design a pack and implement that into this Karam concept, and see, can we achieve the mission we need today with today's existing batteries? And the answer is yes, we can actually get through this 3-hour sprint without dropping too low into the battery to need to recharge more. And so we're doing this with a lot of partners. We're not doing this alone. You saw some of our OEM partners there. We're also working with the Army Research Laboratory, with NASA, and working on developing new technologies in key areas that are going to work across this kind of ecosystem that we're developing. So we're working on a stacked co-rotating propeller that allows you to get better figure of merit, lower noise, while still allowing for low drag and cruise. We're doing safety studies with academic institutions like Georgia Tech. And so we would love to work with anyone that's interested in working with us. And so thank you for, hope you're excited for this future. We're talking about 2020 demonstration flights and 2023 commercial operations in Los Angeles and Dallas. So hopefully we'll see you there. Thank you.